Hello and welcome to the Authenticate Summit, the FIDO Fit in IoT. My name is Rolf Lindemann and I had the privilege to lead the FIDO IoT study group that eventually led to the creation of the FIDO IoT Technical Working Group. Initially, FIDO was only focused on authenticating users to cloud services. Then we expanded our scope to include IoT. Let's look at the specific authentication-related challenges in the IoT space. IoT devices capture video streams for surveillance, measure fluid levels, temperatures, gas concentrations, or connect other sensors to a network. They are so small, they are cheap, they don't have a lot of computing power, and some devices even have switches or buttons so people with physical access can use them. So why could they be relevant for cybersecurity? So why do we care? The reason is that in real scenarios, first, if the IoT device doesn't work as expected, bad physical things could happen, not only virtual things. So IoT devices bridge the gap between our virtual world and the physical world. Second, there are thousands of them, or hundreds of thousands, or even millions, and the aggregate computing power is significant, meaning the scale makes them relevant. And that begs several questions. If we have to bring many IoT devices into our network, how do we ensure that each of those small things comes from our trusted supplier, as opposed to being a counterfeit product, for example, the supply chain integrity aspect? How would we keep the cost of installation under control? Installation itself shouldn't be more expensive than the device itself. People that have to install many devices in a short time are more likely to overlook security issues. So we have to make security an integral part of the solution and not an afterthought. And how do we ensure only trusted entities can access and use those devices? And how do other entities know from which entity they got the data? Yes, that is the authentication question again. Sometimes it needs a wake-up call to get things moving on the security side. And here are some. The Mirai botnet attack from 2016. Or in 2019, people reported a 300% surge on IoT cyber attacks. In March 21, another attack on video surveillance was reported. And in May 21, there was a Colonial Pipeline attack. So we have seen many attacks. Let's understand what is needed to make the IoT world secure and where FIDO fits in. So before we dive deeper, one remark: to make ecosystems more secure, you need multiple things. We use the analogy of a robust building here. A strong foundation and a root of trust. Without a robust foundation, there's no way to keep the building upright. And that's the same with IoT. Second, we need device-level attestation to help the supply chain integrity and also reduce the complexity for custom device configuration and device onboarding. Without that, you don't know whether the trust to the fundament is there, meaning whether the building will remain upright or not. That's a slightly different thing than number one, right? The second is about knowing whether you can trust, and the first is have the security measures to make it trusted. But you need to understand from an existing device whether you can trust it or not. And number three, we need to secure the front door. That means authenticate users so that only legitimate entities get access. Without a solid front door, all the foundation and solid walls won't help. So number one is addressed by the silicon vendors. Their approaches include TPMs, Trust Zone, or SGX. Today, we in FIDO focus on approaches number 2 and 3, the device onboarding and strong user-to-device authentication. And regarding my number 3, the robust front door, this is one of the issues that are often forgotten. Many devices have admin accounts that could be used to configure the device. Often those admin accounts use default credentials for authentication, and David has just shared one of the typical passwords for that. And they have the same passwords across all devices of the same model. This topic became so relevant that the regulators had to chime in and address it. And here are some examples. The final report from the President's Commission on Enhancing National Cybersecurity, the California Senate Bill 327. In the EU, ENISA has baseline security recommendations for IoT and adds these technical specifications, cybersecurity for consumer Internet of Things. The UK National Cybersecurity Strategy, and from the German BSI, the cybersecurity recommendations for secure passwords. Bottom line, they all ban shared default passwords. Some might be inclined to think that just using different passwords for different devices will help solving the problem. But that makes device management rather impractical and still doesn't solve the other security and usability issues with passwords. Adding OTPs to the password for increasing the security is not practical for IoT devices, nor does it help against phishing. So here are we back to FIDO again. Right? I don't want to get too much on detail level here, but the interesting observation is that FIDO authentication standards are applicable to user-to-device authentication as well. You will have likely seen this graphic already. It shows how users authenticate to cloud services using FIDO. And you can replace very easily the large cloud environment on the right-hand side by small IoT devices. You just have to scale down the FIDO server accordingly. In the IoT case, there won't be thousands or millions of users authenticating to a single device at the same time. It will typically be a single user or an admin only. The fundamental approach and the protocol details still work in the same way, which is a surprising observation. As a result, you could use any biometric like fingerprints or facial recognition to authenticate to IoT devices. And you could use single device passkeys and multi-device passkeys very easily. We have actually implemented that and had built a demo. Let me know when you are interested. This demo uses a small ARM M4-based MCU with modest memory. The authentication is relatively quick, and it works on constrained devices as defined by RFC 7228 in class 2 or 3. Beyond this demo and concepts, the companies Gallagher and Nok Nok have actually implemented this and deployed it. This is an example for physical access control. So in summary, to make the IoT ecosystem more secure, you need a strong authentication that's the front door, providing phishing resistance and being still practical for daily large-scale use. I focused on that topic in this presentation. Second, you need a robust and practical way to onboard IoT devices. This topic is covered in the following presentations. And of course, you need a strong security foundation. The silicon vendors have worked hard on this in the past, and we can build on their solutions like TPM's TrustZone, SGX, etc. now. So thank you for your interest. You can reach me via email if you have further questions or comments.